Hi all, welcome back to my YouTube channel. Topic that we'll have a look at today is uniform distribution. It is from paper 2 quants. So we will have a look at the question which may not be asked directly in the exam, but concepts that you may learn will have a good applications in the questions that are asked usually in the exam. So yeah, before we go ahead, please do subscribe to my channel, like and comment and share with your friends. Believe me, it takes a lot of efforts to come up with videos like this. Let's have a look at the question. Let me just switch on my pen. Yeah, so we have been given that there is amount of profit for cells which is continuously distributed uniformly with parameters 0 and 1500. So if we think of X as a profit, which is uniformly distribution with parameters 0 and 1500, I'll tell you what does exactly mean. So, however, analyst believes that actual profit is minimum of X. So slightly tricky, and this statement has been given to you just to make you confused because otherwise, in the question that we have to actually address, if there is no need of actually this information, but yeah, let's have a look. What is the conditional distribution of x given x is less than 1300? So some information, and these are the options we will have a look. So before we explore the option, let's have a look at some basics of uniform distribution in context of this example only. So as we saw that x was uniformly distributed with parameters 0 and 1500, it means that the lower bound for this distribution is 0, which has been indicated here, and the upper bound is 1500. So these are the values that x can take. So you can think of this as a profit, which can take values all the way from 0 through 1500. And this is a probability that corresponds to the value of x. Say, for example, what is the probability that you will get profit of 1500? So this is why basically the probability is given. This is a uniformly distributed variable. So profit for all the values of x is given by this 1 upon b minus a. So that's what the uniform distribution means. Now, what we have been asked is we have been asked to calculate the probability that x is less than 1300. I mean, the probability, what is the probability distribution of x given x is less than 1300? So this is what we are interested in. If we want to find a probability, that also we can do, and how we can find this. So if you recollect, just be careful. So one disclaimer I would like to make over here is like whatever solution that you may refer for this question are based on their individual view. I'll explain here with some intuition, which will filter out all the confusions you may have looking at the solution that is given in the book. So we'll go with a very basic layman understanding. So if we talk about probability of A given B, it is probability of A and B divided by probability of B. So same we will apply, and just to relate this question in this formula, that's where the key of this question lies. So let's have a look. I'll just apply. Say for example, A is somewhere, it's just a probability of X in this complete interval. So probability of X and probability of X less than 1300 over probability of X less than 1300. Okay. So this is something which we have to find. Now, if I were to just uh, draw the common area between the complete and values that x can take. And let me just draw it. So this is a boundary wherein just give me a moment. Just think of this as a straight line. Okay. So this x belongs to this complete area from 0 to 1500, and the another part which is less than 1300 corresponds to this portion. So I were to uh, so the second portion in numerator is this complete area, and the first portion, sorry, first this is complete x, which this particular thing, probability of x, all the values that x can take. And this is the second portion where in x is less than 1300. So this is a region. So if you see, the common area is this rectangle. So all the way from, let me just draw some. So this is a region that we are interested in. This is a numerator part wherein we have to find the common area between all the x and x less than 1300. So if you see that it's also same as denominator wherein we have to find probability x less than 1300. So eventually what will happen that it will also be probability of x less than 1300, and in denominator also it will be probability of x less than 1300. So given both are same, we don't need to find it separately. Otherwise, we would have applied some numbers to come up with this. But this both will cancel and answer would be 1. So so the conditional distribution wherein x is less than 100 is 1. It means that, say for example, y is another variable which is fulfilling this, I mean, which is, say for example, x is less than 1300. If I tag this as y, so for y, it is the probability is 100%. That means the initial and the end point would be 0 and 1300. So that's how you can interpret. So if this is a conditional, then the variable which will be outcome of, I mean, if we tag this as a separate variable with for this conditional event, then that event will have these a and b's, 0 and 1300. That's what we had to actually find. And of course, this also would be continuously distributed, and A and B we were interested in. So the option for this particular uh, question, I mean, for this particular Y is similar to A. So the correct option for this question is A. Hope you found it useful. If yes, please do share with your friends, because usually if you search for solution of this numerical, you will hardly find it on over the internet. So it could be useful because it's not purely formulas based, but it is based on your intuition about uniform distribution. Thank you. Stay connected.